Unmute. Excellent. Yeah. Yeah.
Okay, you mute your mic.
Yes. How's that? Oh, no, it's this one. Technical difficulty. The more technical the sort of speakers and audience, the more this stuff happens, I think. Okay. Yes, okay. So I'll go now. Yeah, so why am I here? I'm here because, well, I've known Taylor for a very long time. I can't even remember for how long, but for pretty long, back in the Hunter College days. And so I was an assistant professor in the geography department there at Hunter College CUNY and at the University of Colorado Boulder. And that was lots of fun. And my background was in geocomputation and sort of like computer sciencey type things applied to geography. My research focus was on human mobility and geospatial data streams and all that fun stuff. And then in about 2016 or something like that, someone from Carto, which is what is now CartoDB at the time, was a geospatial startup. Someone from there approached me and said, hey, we had fun doing stuff with you before. I'm starting a new company. We're doing sort of geospatial on-device machine learning, but like he had all the right buzzwords. And I remember I was like, it'd be super irresponsible for me to leave a, academic tenure track position to join a startup that hasn't even really started yet. So yeah, let's go. And so that was about 2016. I left academia and joined this geospatial focused machine learning startup. And there's lots of funny reasons for why we kind of pivoted out of that. But in 2017, some of our funders told us about this like Filecoin project and IPFS and that sort of thing, because we were coming up against a real problem that we had in our own work, which was that users user data and sort of like the ability for users to have autonomy over their data and to control where their data was stored was sort of like actually a real problem that we were coming up against in our mobile machine learning startup. And so we discovered IPFS and sort of deep dove down this geospatial or the decentralized web rabbit hole. And now I think it would be very difficult for me to kind of go back. Now that I've sort of seen the sausage of the decentralized web, it would be very difficult for me, I think, to go back. And so I'm hoping that in the next couple of slides, I can give you a little overview of sort of how we arrived where we did in terms of my team and some of the features of the decentralized web that we find particularly compelling for, data in general and user data in particular and potentially geospatial data specifically. But anyway, I left all that academia behind and now I just work on distributed systems and databases and things like that. And I'm happy to delve more into what I do on a daily basis if anyone cares. But I thought basically I'm the first talk, so I'll do kind of like decentralization 101, and hopefully that will help a little bit set the stage for the rest of the afternoon. So there's tons and tons of like, if you ask someone, to define decentralized or decentralization or something, you'll get a different, answer every time. But Corey is from the Internet Archive and other groups, so you might as well go with that. And so he talks about a system designed to resist attempts to centralize its architecture, services, or protocols so that no individual state or corporation can substantially control it. And I think this is a pretty good one. This is a sort of like useful one from a high level. What's the, what's our ethos or our, what are the things that we actually care about from a high level? And so I'll go through a couple of those different topics that he mentioned there. But there are a lot of other useful reasons why a decentralized web or a decentralized system is useful, and I want to touch on some of those as well. But according to that definition, it's a lot about redistributing control from what's generally some sort of central authority to a distributed network. But it's not necessarily sort of like taking away control or like sticking it to the man or anything like that. In a lot of cases, it's actually these are efficiency gains that we might get, or these are moving control from sort of a centralized repository of data directly back to the data providers or the data producers. So it's not always a sort of like pushback against the man kind of thing. Sometimes it's actually just a redesign or a rethinking of the existing design. And in a lot of cases, the importance of decentralizing something is really about addressing potential centralized points of failure. For instance, if you're relying solely on a single web service and that web service goes down, now your users no longer have access to the data that they require for their workflows or things like that. So it's trying to eliminate things like that in a lot of cases, but also eliminating things like single points of failure in terms of governance or control over that data, or potentially even where that data is stored or who has access to it and things like that. As a byproduct, this is sort of loosely true. A lot of decentralized systems promote privacy, or at least promote cryptography and as a means of controlling access and things like that. And in a lot of cases, as a byproduct, also ensures ownership over that data, because in a lot of cases we shift, and I'm going to talk about this quite a bit at the end, but we shift kind of the burden of ownership from a single centralized system onto the actual data producers in many cases. Anyway, so let's see if we can kind of explore a little bit how we can influence various aspects of a data production pipeline, and in particular, how we can use that for scientific stuff. Right, so I can kind of go fast on this slide, but this is a classic figure that we use in a lot of cases when talking about decentralized versus centralized or distributed systems. It's actually from 1964. It's the original reference at the bottom there, talking about communications networks. But it gives you a good picture of sort of like how these systems are designed from a physical infrastructure point of view, but also from like a decision-making point of view, from an ownership and access point of view, and from a governance point of view. So centralized is obviously the one where everything has to go through. So that could be like decision-making, that could be where you go to get your data, that could be all sorts of different things. A decentralized one is a bit more of a sort of natural web-looking system where you have some sort of centralizing features, but in many cases, if this centralizing node is acting maliciously or not doing its job, then a lot of the other nodes in the network can circumvent it and access it, and access data or the network in other ways, versus a fully distributed system where everybody is connected to everything, and it's fully sort of very resilient, and it's basically what we're talking about is a peer-to-peer network on the far side there. And that's something to strive for, perhaps, but it's not always particularly doable or useful in a lot of cases. So according to that quote and some of the other ideas that we've talked about so far, there's some sort of principles that we often think about when we're talking about decentralization. User control over data, sovereignty over data, often identity plays into it a bit. But then there's also technical features as well. Networks, decentralized networks tend to be a little bit more resilient. So they continue to function if some piece of that network falls off or some service stops providing. And then encryption and access control and things like that tend to be byproducts of this sort of decentralization process. But one thing that I think doesn't get talked about as much when we talk about decentralized systems, that is particularly important, and I'm going to touch on this a bunch of times, is this concept of sort of permissionlessness. Permissionlessness, I don't know if that's a real word, but permissionless systems. Yeah, the ability to participate in that network or system without approval from some centralized authority. And this is a really interesting feature. It comes up a lot in sort of like blockchain contexts, but it applies quite nicely in decentralized systems writ large as well. And the idea is basically that in order to participate in a decentralized system, you basically just have to follow the sort of preset rules for that system. You don't need to ask for permission. You don't need to buy a special license or hardware device or anything like that in order to participate. In general, when you have some sort of like economic system baked into that, which we'll talk about in a second, this can often sort of encourage folks to experiment and innovate on top of this pre-existing system, because they don't need to say, hey, is it cool if I make an app that does this particular thing on top of your network? They just build that app and make it work on top of the network. And then if people like it, great. And if they don't, then they don't. And I'll show some examples of this in a little bit. There are also a bunch of really nice side effects of this in theory, which includes inclusivity, i.e. people who you don't really know suddenly are able to start using your network or your peer-to-peer system in ways that you maybe didn't anticipate. And then it also brings with it some resilience factors as well, because we actually can enhance the robustness of the network by actually diversifying who and what and which organizations and individuals actually participate in. So the classic example, right, of this would be that in a cryptocurrency or in a blockchain scenario, we have smart contracts that execute code based on sort of predefined consensus rules, instead of sort of like asking, hey, is it okay if I transfer these funds from Steve to Bob or from Jane to Ryan? Instead, there is already a set of rules, and I can do that if the rules permit, and they're out there for everybody to interact with. So we're going to go back to some of those concepts in a little bit, but permissionlessness is an important feature. There are also lots of technological foundations for decentralization. This is a highly opinionated slide, and you'll hear from other people in other contexts. Because we're here, Filecoin Foundation is funding this, and because that is my entry into the decentralized web. Content addressing, I think, is a particularly important technological feature. I mean, heck, even Netflix and like large corporations like that find this a useful technological foundation for building systems on top of. And Volker's going to talk about what that actually means in a little bit. So I'm just going to tease you with like there's this important thing. In general, peer-to-peer technologies are a technological foundation for these types of systems. So being able to communicate directly between nodes or individuals or organizations within a network is pretty important. Not having to go through some sort of intermediary is a kind of key piece of these systems. So a lot of peer-to-peer technologies have been developed and sort of optimized and improved in the name of decentralization. It's often associated with blockchains, but the decentralized web does not require blockchains. If you ask the early developers of the web, how they wanted it to work, a lot of them do cite being able to do like direct peer-to-peer payments when interacting with websites. And so far, blockchain has sort of emerged as the best and most obvious way to do that. And so there's a lot of, sort of like similarities between the values and things that we're trying to get done in Web3, in blockchain technology, and the decentralized web. So blockchain tends to play a key role. And then identity is another big one. And identity is a very overloaded word, but in general, it means some sort of like representation or some way to uniquely reference an individual as they morph and change and move about some sort of internet of data, web things, or whatever, but some way to identify individuals. And then, as Taylor mentioned earlier, it's really important to remember that it's all sort of in degrees, everything in moderation. There is no such thing as like it is decentralized or it's not. It's generally a continuum from sort of slightly decentralized, like some of these federated social networks that are emerging. Mastodon was sort of an earlier example. Farcaster, Blue Sky, all these different sort of alternatives. To like fully decentralized, like blockchain networks or like Bitcoin. Bitcoin is about as decentralized as you can imagine in a lot of cases. And there are factors along this continuum. Like there's different governance models. Some of them are very decentralized, every vote has to happen on some blockchain somewhere that's fully verifiable, right down to, you know, just about the vote on who gets to vote happens on chain and everything in between. The technological infrastructure can or cannot be fully decentralized. In many, many, many cases, a lot of these decentralized networks and systems rely on AWS or Google Cloud services or things like that to store things or handle their community engagement on Discord and things like that. So there's no sort of one size fits all thing. But there's lots of examples of where one end of the spectrum and the other works. You know, the classic example is Bitcoin's decentralized and banking systems aren't. That's obvious and sort of boring, but that's sort of a good example. Another one is like Wikipedia or OpenStreetMap versus sort of government or mapping agencies. You know, OpenStreetMap is quite decentralized. They use physical centralized infrastructure, but the people who can participate and the governance structures and things like that are fairly decentralized. I hope someone's going to tell me when I'm running out of time, by the way. And then, of course, it's not all perfect, right? There's lots of reasons why decentralizing something doesn't make sense, and which I think that'll come up quite a bit in today's discussions and tomorrow. Sometimes it can be really hard to scale these types of systems. Imagine if you have a decentralized governance structure where everybody votes on everything, right? Like that doesn't scale very well. It's very difficult to apply that. Even physical like infrastructure and technological problems can arise when you try and scale some of these systems. Regulation is really quite tricky. It's very easy to point at a centralized system and say like, oh, that thing's doing something wrong, or that thing is, you know, not designed correctly, or this individual is running that wrong. It's much harder when all of those individuals are potentially anonymous, are in different jurisdictions, and are operating across different boundaries. So regulation can become very difficult. And then, of course, there's this sort of signal to noise that can be quite a problem. Especially as soon as I'm always a little bit to like mention cryptography and crypto and blockchain, because everybody gets a little bit the backs up in some context. But like there are scams, there are like any nascent technology, there are people who try to take advantage of the naivete of the networks and the newness of the technology. And so you have to deal with that noise to signal ratio. But one thing I always like about sort of like constraint-based systems is they tend to breed innovation. So there are a lot of new opportunities when you have to operate in a decentralized system for creating sort of new, different, transparent, and potentially even more efficient processes for dealing with data. So there's a bunch of examples. I'm going to kind of skip over these and get to some more interesting ones. But in a lot of cases, we can move from like, you know, traditional finance to DeFi, where we replace sort of intermediaries and permission-based systems with smart contracts. Social media platforms, you know, moving to more peer-to-peer, direct peer communication, where you have a little bit more control over what you see instead of going to the algorithm that you get from a social media platform, right down to like supply chain management in mutually untrusting systems or networks of individuals participating in the same supply chain. They can actually use decentralized ledgers to enhance transparency and actually operate in sort of like less trustful environments. But one of such network that I did want to talk about for a quick second is Filecoin. And the reason for that is I work in this space quite a lot. We've been operating on the Filecoin network for a long time. It's what you might call foundational, and I stole some of these concepts from a really great talk by the creator of Glow, which I'll talk about in a second as a case study. But he calls Filecoin a foundational DePIN project. Huge project, lots of storage providers. This is an example of a network that has sort of potentially will displace an existing incumbent with a decentralized system. And they already have clients that include, you know, Berkeley and CERN and Shoah Foundation. But what the really interesting thing here is they've sort of like replaced service with competition. So in this case, basically the Filecoin network writ large it does the marketing and all the business end of things in a way. And then there are a ton of service providers, storage providers that compete to provide the service that they want the network to provide. And this leads to a bunch of, in theory, optimizations, right? Because now I don't have to, if I want to participate in this network, I don't need any permission to do it. I just need to build my like super high performance data center, put that on the network, and start participating and gaining traction on the network. And if I can undercut the price of everybody else, that's fine. That's great. Now I'm going to make more, I have lower margins. I can make more participating in this network. And in theory, overall, we've got an open network. So prices, should lower as I get more and more participation who can offer a cheaper and cheaper service. So there's a bunch of optimizations and efficiencies that we can get from actually competing at a service provision level instead of trying to build a whole new system. So imagine trying to compete with AWS now. You'd have to have like a huge marketing team. You'd have to have sales and SLAs and customer service and all that stuff. And so even if you could build a better system, you'd never be able to deploy it. But because you can operate within a permissionless system, you can hyper optimize the service that you provide. And then you let the network do a lot of the sort of broader marketing and things like that. And now individuals can actually compete. I could actually spin up a Filecoin service or storage provider tomorrow and start participating in that network and potentially sort of undercut prices and things like that. And actually sort of like really innovate in ways that you can't really do when you need to ask permission first in order to participate. So if you take away nothing else from this talk, it's the main thing to think about is that these systems often allow for permissionless participation, and that is a pretty useful property when we're trying to sort of like promote innovation and open access to data. And I have lots more examples, but I'm out of time, so I'm happy to chat with anyone about this afterwards or throughout the next couple of sessions. There's some great examples of this working in practice, and I'd love to share those with you. So thank you very much. I'll skip to the end here.
Time for a couple of questions. I was just intrigued. Could you say a few words what it's about?
Oh yeah, actually I had a good example of you guys in here too. Just ran out of time. Yeah, Glow is this interesting project where they're trying to incentivize individuals to install solar panels and to put like basically to put the energy that they produce from their solar panels back into like traditional markets. And so you can install any solar panel that you want, and then you register your solar panel with this overall network, and you basically track how much dirty energy you're offsetting to the network. And the idea is that they will then, you get sort of like a kickback from the network in order to fund adding more solar panels. So it's a sort of system designed to fund adding solar panels. And then they buy carbon offset credits with that revenue from the network in order to keep it sustaining. And they've got an interesting model where they basically get funding from large sort of green energy funding projects in order to like put money back into the network to keep individuals building solar panels. And you can sort of actually pay for your like solar panel investment through the network in theory. So it's fairly low cost to add it. And it's as much as like one panel on your roof in some neighborhood somewhere is enough. Anyway, the economics are kind of complicated, and but it's an interesting project where they're trying to fund some public good and do the right thing. Yeah.
Very drafted, no thoughts on what trust is in this as opposed to
Yeah. So you'll notice I did not actually use the term trustless at all in any of these slides. I don't really like that term. but it is a term that gets used a lot in sort of blockchain, cryptography, like worlds where, you know, you get the sort of slogans of like, verify, don't trust, or in code we trust, and these types of things. And the reason I didn't use that term is because actually, like you do trust, there is a lot of trust in these systems. You trust that, you know, the cryptography works, that the math is right. You trust, in a lot of cases, like, so Filecoin's a good example of like, you know, there's cryptography to back up, like, yes, this data is actually stored. I really do have these bytes on my system, but you trust that like they're going to continue to operate under the rules of the, like, they could be slashed, but like, if they're not an economic actor, they don't care. So there's still a lot of trust involved in these systems. But the permissionless aspect I like, because in the permissionless world, you can sort of start to participate and you actually, in theory, build trust through your reputation, through your sort of like persistent identity. So I think shifting away from thinking about like trustlessness isn't really a feature. Like, human beings want to be able to trust each other. Like, that's part of how we interact with people. So I like that you can build trust permissionlessly in a lot of these networks by just participating and doing, like, playing by the rules of the network, in a way that you build up reputation. And so, you know, there's a really great post by someone from the Filecoin ecosystem, Jonathan Victor, and he was talking a little bit about like how much needs to be on chain, backed by cryptography, like irrefutably true, and how much could be done just by sort of keeping all of the trust and reputation and things on chain. But then you can see like, okay, Steve's data center has 100% uptime and has never lost any data. So I'm going to like go into some sort of an agreement with Steve because I can see that all of his participation and all of his interactions have you know, led to a very trustworthy system. So I don't need to necessarily like do all the expensive cryptography that is involved in proving my data is stored. If I can look and say, okay, Steve is quite trustworthy, I'll interact with Steve directly. Excuse me. So you still have this peer-to-peer system backed by sort of like cryptography and sort of transparency that is also leading to building trust for like off-chain operations and things like that. I don't know. That was a very long-winded way to hopefully answer your question. Cool.